What makes some elements magnetic? The current theory. A popular theory of magnetism considers the molecular alignment of the material. This is known as Weber's theory. This theory assumes that all magnetic substances are composed of tiny molecular magnets. An unmagnetized material has the magnetic forces of its molecular magnets neutralized by adjacent molecular magnets, thereby eliminating any effect. A magnetized material will have most of its molecular magnets lined up so that the north pole of each molecule points in one direction and the south pole faces the opposite direction. A material with its molecules aligned will then have one effective north pole and one effective south pole. Later expanded, Weber's theory said that under ordinary conditions, in unmagnetized state, a substance has a number of tiny magnets grouped together in a way that these magnets form a closed compact chain, so that the various north and south poles neutralize one another. Also, it has been experimentally proven that an electron has a magnetic field along with an electric field. This is the domain theory. If an atom has equal number of electrons spinning in opposite directions, the magnetic fields surrounding the electrons cancel one another, and the atom is unmagnetized. However, if more electrons spin in one direction than another, the atom is magnetized. Since they need to be aligned, elements in gaseous and liquid states are not magnetic. Often magnetic materials tend to be metals as alignment easily stays in place and do not move away. How valid is a theory? The theory can be considered valid due to extensive research completed by a variety of scientists and the evidence they have received to prove the two theories correct. Even though domain theory is much more modern when compared to the Weber's theory, both have great amounts of scientific evidence and observations that have proved the theories correct. The theory has been proven correct right across the world through many scientists who have conducted personal experiments resulting in the overall positive outcome of the theory. Nevertheless, the theory of electrons and electron alignment are reliable due to the simple terms we have learned through polarity and subshell configuration, where the polarity is affected by the number of electrons. In addition, observations have been proven correct about the alignment of north and south poles through the elements such as iron, nickel, and copper, who all have magnetic properties. Scientists have clear evidence to prove electric fields are causes of magnetism due to several leading factors. Change over time. The history of magnetism dates back to earlier than 600 BC, when the ancient Greeks were the first known to have used this mineral, which they called a magnet because of its ability to attract other pieces. It is most likely that the Greeks discovered a form of the mineral magnetite called lodestone, which consists of iron oxide. But it is only in the 20th century that scientists have begun to understand magnetism and develop technologies based on this understanding. The Englishman William Gilbert was the first to investigate the phenomenon of magnetism using scientific technology. He discovered that the Earth is itself a weak magnet. Frenchman Charles Coulomb established the inverse square law of force, which states that the attractive force between two magnetized objects is directly proportional to the product of their individual fields. Soon after, James Clerk Maxwell provided the theoretical foundation to the physics of electromagnetism in the 19th century by showing that electricity and magnetism represented different aspects of the same fundamental force field. Impacts. This phenomenon has a lot of impact in society, as magnets are often used in industrial areas as well as in our daily lives at home. It is never really thought about. However, there is a real science behind to this idea of magnetic materials. The most important use of the magnet is the magnetic compass, which is used to find the geographical directions. The use of magnets in the medical sciences is very effective. We can use magnets therapy for the pain management without any use of the medicines. The magnets can stimulate the nerves in the human body and increase the blood circulation around the body. Doctors use the magnets to cure arthritis, spondylosis, and other problems related to the nervous system. Also, metals are often used in mining to separate metals from ore. Along with this, there are many uses of magnets at home. The negative hazardous impacts of magnets on the environment and the human body are currently being researched, but to this point there have been no records of magnets being harmful to the body. However, there have been identified physical hazards throughout the industrial areas which need to be controlled. Some other information. The formation of permanent magnets are the result of ferromagnetism. The prefix ferro refers to iron because the permanent magnetism is first observed in a form of natural iron ore. These naturally occurring magnets are called lodestones, discovered by the Greeks. People soon learned that they could magnetize an iron needle by stroking it with a lodestone, causing a majority of the unpaired electrons in the needle to line up in one direction. Other metals besides iron have been found to have ferromagnetic properties. These include nickel, cobalt, and some rare earth metals. Also, paramagnetism occurs when a material becomes magnetic temporarily when placed in a magnetic field and reverts to its non-magnetic state as soon as the external field is removed, clearly described in the diagram. When a magnetic field is applied, some of the unpaired electrons spin, aligning themselves with the field and overwhelm the opposite force produced. However, the effect is only noticeable at very low temperatures.